But that brings us to our next segment. Ken is going to bring us the 3D printing application of the month. What do you want to talk about, Ken?
Sure. So last week we talked a little bit about functional prototyping, so I wanted to do another more functional topic this week again. Wanted to talk about fixturing, so jigs and fixturing, and specifically why companies are looking to additive to make these things. Traditionally, a lot of jigs and fixturing have just been done using just machine components or plastic injection components, but why they're specifically looking to additive, and then on top of that, talking about a couple specific cases that are unique to additive and reasons why companies are using specialized materials for their jigs and fixtures. So the first one, I guess, more of a question would be, why do you think people use additive for this as opposed to just traditional methods?
Probably from the customization. Sorry, I'm not bad.
For jigs and fixtures?
Yeah, jigs and fixtures.
Well, it does free up use for your big machines so you don't have to take them offline to create a jig or fixture.
Yep, that's one part of it. So basically taking non-customer or non-value-added tasks off of your CNCs and your other manufacturing machines. Kevin, did you have
I was going to say customization, right? So, I mean, your product is going to change, so if your tooling doesn't change to support it, then it's not going to be very functional. So I would imagine having flexibility would be a big benefit.
I've got
that's
one.
definitely a big reason.
I would agree with that, but I would also say that something we haven't touched on is just sheer capacity. If you have a dedicated tool room and dedicated employees who work full-time in that tool room, they can pretty quickly get overloaded just with requests from different departments. And so having kind of like an extra set of hands that you don't need to physically be there working the machine to make something, I think is a huge benefit.
Yeah, and I know with my last employer, it was a factory setting, and for that machine shop, there was about a 3-week lead time on almost everything out of the machine shop. So basically how I got any of my prototype fixtures out was a bag of combos to convince the machinist to stay an extra 30 minutes. And that was for every single one of my prototypes.
Did you just buy combos in bulk after a while? You would just go up to Costco, get a huge pallet, and then anytime
Are those the
you need
ones
one,
you
you
stick
just
on your
hand them
fingers?
No, those are bugles, Ben.
Oh,
Those
bugles?
are bugles.
They're your snack chips.
I was just picturing a machinist with his fingers covered in bugles, but
No, never bought in bulk, but I was getting close. But there was a lot of Funyuns and combos exchanged for parts.
You gotta do what you gotta do. Honestly, I think a bag of combos in exchange for half an hour of overtime is probably a pretty good deal.
Okay, so I'm going to feign a little ignorance here, and I may get shouted on the comments later, but that's okay. Can you roll through some examples of jigs and fixtures? Like, I know drill guides and, bracket holders or things like that sometimes, but what are like some of the most popular examples of like jigs and fixtures?
The most common one that would pop first in my head is like an assembly aid. So whether that be something to hold a component or to, I guess, kind of guide an operator to do something correctly. I know a popular one I worked with in the past was like a welding fixture. So if you had to weld two components at a perfect 90-degree angle, you would put it in a fixture, not like gas. You're not holding the two pieces up while you're trying to weld it. You just place the two pieces, clamp them into the fixture, and then perform your task. That way you're always getting the right angle.
Sure. Okay.
So a lot of fixtures are like that, where you're forcing some level of quality by using the fixture.
I just wanted to make it real for a second. I feel like we use the terms jigs and fixtures really loosely in application, terminology, but I feel like it warrants diving like, what is that specifically?
Kevin, I got another one for you.
Please.
Vice jaws.
Sounds terrifying.
Yeah.
It does kind of sound terrifying.
And you don't damage the piece that you're working on.
No, vice Jaws is in case Jaws gets caught, then he's the new Jaws.
Not the shark. Not the shark.
Hey.
Boo! You know,
I
Kevin.
thought the comments were going to be bad before.
I know, right? Yeah,
Kevin,
that's
did you
okay.
just come up with that now?
I did, on the fly.
Nice. I like that. I like
Thank
that
you.
a lot. I might steal that next time we're talking to customers about this sort of
About
thing.
vice Jaws specifically, you're welcome to.
Yes.
Freelance.
But in machining, vice jaws, say you go out and you get a casting made, right? You only get castings made when it's more efficient than machining away from flat stock, bar stock, rods, whatever that is. So then now you have this complex shape, but you need to do post-machining on it for your critical surfaces. It's a weird shape, which means you need custom jaws so that you can clamp it in place in your CNC machine so that it can cut away the critical surfaces. 3D printing is a great application for that because it's a complex shape. Like Ben said, it doesn't scratch the surface of the workpiece because it's made out of plastic. It can be made quickly without a machinist having to take time away from another job. It's a great application.
That's a cool
something we talked
application.
about with another customer was laser marking fixtures. And so you have a part, you want to put it in your laser engraver, and you need something to hold it. Again, assuming it's not just a flat sheet of something, you need something to hold it in place at the right angle so that the laser can go and engrave a part number or anything else on it.
I saw that on Shark Tank.
What?
There was, I saw that not exact, but something like that on Shark Tank, where there was this company that was getting 50 caliber shell casings, and they were turning them into beer bottle openers. And they had a laser engraver, and they were putting like one shell casing at a time on it. And then they made a fixture where they could put like 100 on their laser engraver at a time and do 100 at a time versus just one. And they thought that they would help the problem before they made the fixture, and they bought like 4 more laser engravers. So when they went on Shark Tank, they're like, why do you have so many engravers when you have such a big tray and you're doing one shell at a time? So that was a great example.
That is a perfect example, actually, because if you think of like a shell casing, it's not a flat sheet that just easily goes into the laser cutter and you can cut out a bunch of parts. It's rounded, it's thicker at one end than it is on the other. 3D printing a fixture for that so you can line up 10 or 20 shell casings, hit go on the job, and come back in 30 minutes, hypothetically, instead of 30 seconds because you were only doing one shell, is a great fit for a fixture.
Can you imagine that mind-numbing job that guy had before the fixture? Just staring at a laser engraver all day long when he could have just had a fixture?
I really can, actually. I used to
Yeah.
run a makerspace in college, and we had a laser cutter / engraver, and I would regularly stand there and place things in the laser engraver and hit go, and then run back to my laptop, send the next job over, hit go. Yeah.
You needed a fixture.
I did. I needed a fixture.
A big part of fixturing is ergonomics. So protecting workers from having to move in awkward ways or put torque in odd angles. That's a good way to prevent your company from having to pay higher and higher injury claim bills. So there are some companies that strictly use fixturing just for the ergonomic aspect.
That's a good point.
I think the second part I wanted to talk about was specialized materials. So when we talk about specialized materials, there's different types of fixtures for different industries. So some of the most common, and one of them you guys already brought up, but the first one is those non-marring fixtures. So when you're dealing with objects that have painted surfaces or highly finished surfaces, you're trying to find a fixture that won't damage that surface after that paint or finish has been done. The second one that I think is probably the most common for us would be ESD capabilities. I don't know if somebody
What's
wants.
that?
Does anybody know what ESD is?
I do.
Kevin, go ahead.
Electrostatic dissipation.
There you go.
Did
Basically,
you
yeah.
Did you really know that, or did you look that up?
Yeah,
Like ahead of time? I've never heard of that.
It
I
basically
sit
all
through the
it is
webinars, Ben.
Webinars, yeah.
Oh, I don't do those.
All it really is for companies who are manufacturing electronic components. So think of like PCB boards. The fixture allows charge to pass through it to a grounded surface. So that way, with a traditional fixture, what might happen is if a charge is created or given to the board, a insulator would pass that and ruin a component in that board. So by using ESD components, we're allowing that charge to dissipate. And then the last one was the chemical resistance. And I know we talk about some of our higher level materials like the Antero or the polycarbonates or Ultems. I know you see those in the aerospace industry, but I even saw one customer example I can think of as a paint company was looking to make fixtures that could survive MEK. So just being exposed to that chemical for long periods of time.
I know that one too, Ben.
I don't.
Kevin, what's MEK?
Ketone.
Methyl ethyl chloramide.
Ketone.
Ketone.
Methyl ethyl ketone.
It's nasty stuff. It's really caustic.
I
So
usually
it's a nail
explain
polish remover.
No, far worse than that.
Yeah, I usually explain it as like super gasoline. Like
Yeah.
it's really nasty. It'll burn your skin off.
Yeah.
Don't play with it in the backyard.
But if you can 3D print something that will not dissolve away in that, right? Is that what you're saying?
Yeah, so ironically with materials like I believe our Antero, which is the PEC-based material, it actually gets slightly stronger when exposed to MEK, which I found rather interesting.
It's like a supervillain.
Don't ask me why, I don't know why that is chemically, but its performance actually slightly improves when it is exposed to that chemical.
I didn't know that. That's pretty crazy to think about.
Yeah. Chemistry's weird anyways.
It is. But there are some applications where even like metal fixtures react badly with the processing chemicals that you want to be able to use. Like if you're using an acid etching thing, plastic might resist that better than a metal fixture. And so it makes sense to print them.
Yeah, and then ultimately there are cases where just metal is still the go-to. So like if you have high wear and tear on fixtures, I mean, beyond what's capable with your Ultems and PCs, yeah, they still make sense sometimes. So it just depended on the situation.
I think that brings us to our next segment, you guys.
Thank you, Ken.
Thanks, Ken. That was a fun conversation.
Anytime we can talk about methyl ethyl ketone is a good time. So